Okay guys, I'm here to help you with your Unit 2 practice test, okay? It looks something like this. So I want to go over it with you so that you're prepared for your test. Your test is going to be very similar to this, the same contents, similar questions, but of course not exactly the same. So you still need to review your notes, your labs, and your other homework to make sure that you're fully prepared for the test. But this is a good start. Okay, so we're going to start with Standard 2.1. Okay, Standard 2.1 is the one that tests us on that. We know the difference between elements, compounds, heterogeneous mixtures, and homogeneous mixtures. So let's start with the difference between elements and compounds. So remember, an element is one type of atom. Okay, so one type of atom. So it could be something as simple as nitrogen, okay, which exists as N2. So the fact that there's two of them doesn't matter because they're both N, or they're both nitrogen. So that's still considered an element. If I were to draw this as a picture, it would be two of the same atoms bonded together. Okay, sometimes atoms are not bonded into molecules like that though. So for example, it could be something like gold, pure gold. Au is the symbol for gold, okay, from the periodic table. Gold is, oh, that's a weird G. Okay, gold, if I were to do that, it would just be a single atom, just like that. Or I might show lots of gold atoms all together as a solid. So it would be the same atom over and over again. Okay, over and over, the same size, same color. Okay, another example of an element might be something like helium, He. Okay, so it has two letters, right? Just like gold, but capital letter lets us know that it's the start of a new element. Okay, so this would be the symbol for helium, and I might draw my atom like that, okay? If I were to draw a picture of it, just to let you know it was different from all these other ones. The elements that once you get your periodic table, they'll be easier to tell because they are all listed on our periodic table. So that's an element. The next one is a compound. So the definition of a compound is two or more different types of atoms bonded together, chemically bonded, I should say. Okay, and another characteristic of a compound is that not only are they chemically bonded together, but they're always chemically bonded with the same ratio. So the ratio between the elements does not change. Okay, so for example, carbon dioxide. Carbon dioxide is made of two elements, two types of elements, carbon and two oxygen atoms. Okay, so carbon is one atom, oxygen is the other atom. They are bonded together, so they are written together as a formula like that. Another example of a compound would be water. Water is H2, so there's two H's and an O. Okay, so maybe if we were to draw this in particle form, you would see a C and two O's, like so. Okay, and if I were to draw a lot of them, it would always be the same ratio, 1 C to 2 O's, like that as a particle diagram. Water, I would also have that, and I would have my two H's. Okay, and it would always be the same ratio. Okay, they can have different orientations, but it's always going to be the same ratio over and over again. Okay, so that's the difference between an element and a compound. Once more, an element is a single type of atom, one type of atom only, whereas a compound is two or more types of atoms that are bonded together, and the ratio between those atoms is always going to be the same. Okay, so the next one we're going to do is the difference between homogeneous and heterogeneous mixtures. So remember, homogeneous mixtures are two or more things that are mixed together. They are not chemically bonded, they are only mixed together, and they are smooth throughout. So another word for a homogeneous mixture is, we call it sometimes a solution. Okay? They're evenly mixed together, so you can no longer tell the difference between the different parts. Whereas a heterogeneous mixture is when two or more things are mixed together, but they're not mixed evenly, or they are not able to form a solution so that you can not tell the difference between them. So let's look at some examples. So if I add salt to water, okay, and it dissolves, that would be a solution. Okay, so that would be NaCl is salt plus H2O is water. Okay, so I add them together. They do not react chemically together. They're only mixed together. And then I could easily separate them by evaporating the water out. Okay, so this is not a compound being formed when you mix them. Nothing new is being formed. They are just simply mixed together. The salt dissolves, and now you have salty water. Okay, a heterogeneous mixture, however, an example would be salad dressing, Italian salad dressing, we'll say. That's the one where you have vinegar and oil. They don't mix, right? So they separate from each other. You can clearly see where the oil is. You can see where the vinegar is. Another example that I used is granite. Granite is a type of rock where you can see the different flakes or the different types of rock that's in there due to the different elements that they're made of or compounds. So you see the little black flakes, you see the little white flakes. Cereal is another example of a mixture. You add milk to your cereal, it's mixed together, but you can clearly see where the cereal is and where the milk is. Okay, so that's the difference between those. When you see these written, if their formulas are written, they'll be added to each other. Okay, another example is air, right? Air, when I'm breathing oxygen over here or over here, it's the same amount of oxygen, right? Because the gases are evenly distributed throughout each other. So if I were to write air, it would be nitrogen plus oxygen plus carbon dioxide plus water. Okay, they're all, but you cannot see the difference between them. They're completely spread out, evenly spread out. Gatorade is another example, right? Your first sip and your last sip, even though the temperature might be different, the taste is exactly the same. Same amount of sugar and salt in both of them because they're evenly distributed. Okay, so when you're looking at your quiz here, the answer key can be found on the website, but you need to keep these things in mind when you're doing that and see if you can't do it yourself first and then check your answers.